Let's see. So, what I want to relay this to was, earlier in this week, we spent time talking about graphing single variable inequalities, where you had well, before we get to this, when we talked about singular inequalities, you all right there? That's awesome. Let's say you had an answer like that, x is less than 8. When you graph that, what we did was, we placed what our answer was on the number line and said, hey, that's 8. Now if you think about it, the number 8 then represents one place upon the number line. Half of all of the possible numbers are to the right of it. I'm starting to remember which way it was. To the right of it. It's so weird to say right when you're using your left hand. And then half of the numbers are to the left of it. So that solution is, it cuts it into 2 halves of an infinite set of numbers, if that makes sense. Okay? Now, what I did was I circled that, and then I always ask the question, do I fill it in? Well, this one, do we fill in? No, because it's not an equal to or less than or equal to or greater than equal to. So from here, what you always want to do is find what's called a test point. Well, what that means is I always like to put 0 on here. And a number bigger than it. Doesn't have to be scaled, doesn't have to be anything. And now what we're doing here is basically you're testing which side does it have to be shaded forms. Well, we know that if I put 0 in for x, is 0 less than 8? Yes. So it's going this way. You always cover the truth. You want to be a shady character. All right? Come on, that wasn't bad. That was like decent. For me, that's yeah, it's pretty bad. Now, what happens differently when you get into two variable is that now you go into, instead of being on a number line, you wind up being in an XY coordinate grid. For example. And this is why I said that quick graphing is so important to be able to do. When we quick graph, it makes life so much easier. Okay. So we'll have the inequality of 4x minus 2y is less than or equal to 8. Now, first thing I'm going to do is just draw my xy axis. From here, I'm going to plot my intercepts, just like we did a couple of days ago. You guys remember that? When we cover and solve, if we cover up the value of x, we're solving for the y-intercept. When we cover up the value of y, we're solving for the x-intercept. Basically, we're substituting in the value of 0 for both x and y. So if I cover up my x value, I get negative 2y equals 8. So y has to be negative 4. And my x value is going to be at 2. And I'm just going to plot, I'm always going to label my ordered pairs. Bless you. Now, when I go to connect those 2 points to create my line, do you guys remember when you had whether it was going to be solid or a dotted line? Which is this? Why is it solid? Exactly. Remember that? It's the same basic idea as circling the number. Do you fill it in? You fill it in if it's a greater than or less than or equal to problem. You would leave it as an open circle if it was just a less than or a greater than. It's the same thing when you're dealing with linear inequalities. Linear inequalities are just, it's giving you a solid or a dotted line. In this case, it's going to be solid because of the little bar there. So we connect them. And it looks like that. Now, just like a number line problem cuts the number line half on one side, half on the other, you have half of all your possible solutions above the line and half of all your possible solutions below the line. What you need to do is to determine which side you have to cover up the truth. So instead of picking a single number, you're going to pick an ordered pair to test. What's the easiest ordered pair to test? 0, 0. So if your inequality line that you graph does not go through the origin, use the origin 0, 0 as a test point to see if it is a true or a false statement. So what you do is, well, what's 4 times 0?
0.
What's 2 times 0? What's 0 minus 0? Is that less than or equal to 8?
Yeah.
So that is true, which means we cover the truth. And that's how we shade. You don't have to be super fancy dark shading. If you just draw a couple arrows above it, you're fine. It's absolutely fine. That's exactly what I expect you to be able to do. Okay? What we're going, and I kind of alluded to this, what's going to happen, I think yesterday I showed you guys that section 3.4, where we'll have multiple inequalities at once. You're going to have an overlapped shaded region at some point in time, and that's why we continually make these test points. Okay? Not too bad, is it? Just remember, if your line doesn't go through the origin, great. Use the origin as your test point. If your line goes through the origin, pick any point. It doesn't matter. Use 100 and 100 if you want. It makes no difference at all. It will still work. It's either going to be true or false. Okay? One thing that people do wind up screwing up sometimes, let's say that this was just a less than problem, and you just quickly went through and drew a line and went on and went, oh crap, and you didn't have an eraser. What would you do? Write a note on the side. Exactly. Let's say you screwed up and this is supposed to be dotted, just say dotted. I'm serious, that's fine. It's absolutely fine by me. You don't have to go back and erase it and fix it. Does that make sense? So if you catch it and you're like, oh crap, I should have done a dotted line and you just made it solid, just put a little arrow, make a note saying, hey, this is supposed to be dotted. I'm fine with that. There's no problem with that. To me, that's mathematically okay. Because you caught your mistake and you labeled it. All right, cool. That's all I can ask for. I don't care if you have to go back and erase it, whatever. Some people are absolute and do math in pen. Do you guys do math in pen?
Terrible.
Not yet? I love doing math in pen. Because you have to be... Yeah! Really? I don't like writing in pencil.
Well, because like my handwriting is like so worse, so I need to like erase a lot of like hidden things.
We use those really nice, thin, tipped pens in the math department. So like, it's awesome. My kids steal my pen. My wife steals my pens all the time. Not that you guys care. Oops, sorry, that was really loud. All right, try this one.
I don't know, dude. No question.
Remember, cover and solves, quick graphs, solid dotted line, pick a test point, fill in the blanks. Okay. What's 0 plus 0?
Zero.
Is 0 smaller than 4?
Yeah.
Yes. Pretty quick, isn't it? Pretty quick.
Let me guess your skip.
You know,
Ooh, 27. Maybe that's one. And now you're going less than
Now,
two.
but here's the thing.
Oh, I got this.
This isn't written in the way of a quick graph, is it? You can. I mean, you can change it and just throw it, move stuff around and throw it into standard form. And there's nothing wrong with that. Or could you just fudge it? I mean, seriously, if you get into something that's in slope-intercept form, I mean, couldn't you? I mean, you can move stuff around and say it's negative 3x plus y less than or equal to 11. That gets you to standard form. You can do that if you want, cover and solve. Or just throw the graph in. Here's 11. How many do I have to go up and over? 3. I go up 3, over 1. Up 3, over 1. Or down 3, over 1. Am I just getting a visual representation of what it should look like? Yeah. Do I know what my y-intercept is going to be no matter what? Yeah. If it's in slope-intercept form, you can leave it. There's nothing wrong with that. Is it going to be a solid or a dotted line? It's going to be solid. Needs to make it look like it went through the origin. And if I did this, my x-intercept would have been at negative 11 over 3. Do I need to figure out what the decimal is? Nope. Do I need to write it as a mixed number? Nope. I just leave it as an improper fraction. Oh, by the way, just so you guys know, mixed numbers no longer exist. Okay?
Like, as in, like, terms of you don't want us using them, or they actually
Yes.
don't?
Well, in terms of I don't want you using them, because negative 11 over 3 is perfectly fine. The only time we will worry about a mixed number is later on in chapter 13 when we start dealing with trigonometry, when we have to place 11 pi over 3 as an angle in theta.
Oh. So they don't exist until that point.
Correct, because when you do this, we're going to figure out what this value is, what quadrant does that lie in. Well, when we deal with terms of radians in pi here, it takes 360 degrees to get around a circle, correct? It's also 2 pi around, because that's where circumference comes from. Well, 3 goes into 11 how many times? 3, and how many are left over? 2 things, okay. Negative value in terms of an angle. Remember how we always said negative angles don't exist? Well, they do. Negative angles do exist, they just go the other direction. Positive angles in trigonometry go counterclockwise. Negative angles in trigonometry go clockwise. So this tells me to go around 3 pi.
Math is just
Sorry,
lies.
you're a liar.
1 pi,
Lie.
2 pi, 3 pi is 2/3. If 2/3 more or less than half a pi. It's more, because here's half a pi, so it's going to come around into the first quadrant.
Yeah, of course.
That's the... You guys are all looking.
I see.
So, as he picked up his hammer and saw. The only reason we use mixed numbers later on is so that way we can spin in radians to figure out what quadrant we lie upon to know what our reference angle would be. Which means this is a reference angle of 2 pi over 3, and so on and so on. Which is a 60-degree angle.
Why do we lie to our entire life?
Well, we have to save something for Algebra 2 teachers to show you.
Well, don't you show like imaginary numbers?
You only think that I show you imaginary numbers.
Of course. Oh, the puns.
It's too early.
All right, did this go through the origin?
No.
No. All right. Is 0 smaller than 0 plus 11? Yes. So it is true here. Which means we're shading here. So is it just dumb luck that it's always been true at 0 for the past couple examples?
Yes.
Will it always be true at 0? No. Don't fall. You would be surprised at how many people will say, well, it was right that all the other examples. Yeah, it was just stupid luck. It just happens. Don't fall into that trap.
What if it was smart luck?
What's that?
What if it was smart luck?
I don't know.
We're smart.
Why'd you have to judge the love?
I haven't had enough coffee to deal with you yet. I don't think I will ever have enough coffee.
Do you need more of that dandelion tea?
No, that was gross.
That had a lot of caffeine.
It did. It was something. I don't know. You need to do it.
43.
Decimals are stupid.
I can't actually see it, so
All the decimals.
I just like the
Oh
numbers.
my god.
What happened to the wall?
Blood pressure.
How can you guys read that?
How can you not say that you have glasses on?
Yeah, but it was like missing 3/4 of it.
So it's actually not a bad idea to do an awful looking one like this. So
You're
it isn't because it's written in standard form, isn't it? And if it's written in standard form, we can just go right into cover and solve. Okay. If we go directly into cover and solve, when you divide by a decimal or divide by a fraction, what in essence are you really doing? Multiplying by its reciprocal. So 19 is really, really close to what number? All right, what's 4 times 20? 80. Subtract 4. You get, so you have, if I cover up this, you have an x-intercept at 76.
Wait, what? Yeah, that's what
All right, let me rephrase this real quick, all right? Now, you guys agree that 0.25 is the same thing as 1/4?
Yes.
Okay. How do you undo multiplying by a fourth? You multiply by its reciprocal. Well, what I did was take 19 times 4, but I did this instead. Oh, 20 times 4 is 80. Well, that's just one set of 4s away from this one, so it has to be 76. It's called estimation. Hey, we're on the right side of the pond here. We don't call it maths.
Math, not.
English. No, the English say maths.
Which is really irritating.
Because there's more than one math.
Multiple math.
All right. So it gives you an x-intercept of 76 and a y-intercept of 19 over 3. About here. It's like 6-ish.
Totally just can't.
0 in front. When I connect these two, is it a solid or a dotted line? Dotted line, very good. Did this go through the origin?
No.
No, it did not. So what is 1/4 times 0? What is 3 times 0? What's 0 plus 0? Is 0 bigger than 19?
Yes.
No. No.
Yes, it is.
Okay? No, so it is now false. It's false on this side, which means where does it have to be true? On the other side. So which way do we shade? Of the truth. Liar, liar, pants on fire.
But it's liar, liar, chicken dinner. Oh.
I don't know how I'm gonna make it through this class.
Very well taken. It's not even. What?
Are we good?
I don't know. Or Jenkins.
That's really all I want to do.
Yay. Nice. That's half. Who's ready for
So tomorrow,
She got mad at me because I was
well, I'll give you some problems on these things. It'll be 2, 2, 3, 2, 4, and 2, 6. Those will be the 3 homeworks that I will collect, but what I'll do first of all is that have them out. You won't have anything else on your desk but your homeworks and a pencil. Well, because there's 3 of them.
English, something that is.
Is homework plural of its own self?
Yeah.
It is?
There are a lot of more sheets.
No.
I have a lot of homework.
This is deer. Female deer. All right, so what we do, I'm so sorry. What we'll do tomorrow is, if there are any questions on the 2.6 stuff that we do tonight, which I don't think there will be, to be honest with you, because I'm giving you some time right now to start working on it. What we'll do is we'll check, see if there's anything. If not, I will have you guys did those sheets with 7 with a little plus sign on it, that had certain numbers on it?
I hate that.
That's kind of what I'm going to do. I'll randomly select a couple of the questions of the problems that we did, and then what you'll do is just basically copy down verbatim what you wrote on your homework, staple it together, and hand it to me.
We do it, but it doesn't just make everything worth 3 points. Be easier.
And that's why I figured if we do a little test run on this on a Friday, if it takes 25 minutes to figure out what the heck is just going on, it's not a big deal. Because then tomorrow what we'll do is, in section 2.7, they introduce you guys to function notation, and kind of like the function, you guys know the game Plinko? On the wheel, once they drop down. What they do is they kind of introduce you to the idea of function Plinko, if that makes any sense.
That sounds terrible.
What's that?
I just said okay.
So I think it'll be a really easy thing to introduce you guys to tomorrow after you go through that, because again, that only takes about 20, maybe 15 minutes or so. Then it'll have a couple of problems to look at. Really, it's just do it in class, don't take it home, because it's a 3-day weekend. I want you to enjoy your weekend. And then we'll go back on Tuesday, then we'll start with what are called step functions. And I think they do step functions and what are they called? Multiple graphs on one thing that change at certain values. I don't know. You'll see it. It's kind of weird. We might actually use graph paper on next Tuesday then. Okay? All right. Pick out which ones of these I want you to do. The 2.6. What I will do is on the calendar, I will place the PDF file of this textbook for you, so you don't have to go fishing for it. Oh, they're called piecewise functions. I forgot what they were called. So let's see.
Piecewise.
They don't? They don't play Plinko where they drop the thing down so you can win money?
No, you spin the wheel to get like a number amount and then you make the letter.
Maybe they do.
And the other game is also just spinning with the
It's smaller.
It's just a smaller wheel with more money.
Smaller and more money. I mean, it's not called.
Bless you. We'll do those and give me 1 second. I will put the PDF file.
No, I don't like it.
Bless you. Bless you.
I'm dying. Okay, this is a question. It's the last day of August, guys. I can't wait for holidays. It's the best holiday. Oh, paid. Yeah, well, we can.
Well, as long as it like
I'm not even What's your favorite holiday?
Mine?
Yes.
Hi, Christmas.
Boring. Well, so the thing is that like during Christmas time, Or like
There you go, guys.
and my mom's doing it. So I
Yeah.
can have hot and